All right, this is going over the second page of the balancing formula equations. Um, let's see. So we're going to start just like we did before. We're going to do our atom inventory. We're going to count the number and types of different elements on the reactant side. Same thing on the product side. And just like before, okay, let's see. So we have 1 iron here, a total of 3 chlorine. You'll notice I have ammonium, that polyatomic that appears on both sides. We're going to try to leave that together. We have hydroxide that appears on both sides. So let's try leaving those together as well. It generally just makes your life a lot easier. Okay, so how many ammonium groups? There is only one NH4 group. Okay, there are not four of them because that four only applies to the hydrogen, not the nitrogen. Hydroxide, there is one hydroxide group. Okay, on the product side, 1 iron. Okay, chlorine, it appears there is one. Ammonium, it appears there is one. And then hydroxide, it looks like we have a total of 3. That parentheses around there means there's 3 of everything inside there, 3 hydroxides. Okay, that looks good. Iron is good on both sides, 3 chlorine and 1 chlorine. If I flop a 3 in front of here, that affects the chlorine and makes it 3. But at the same time, it also makes ammonium 3. Okay, now I have 1 ammonium and 3 ammoniums. If I put a 3 here, that a 3 will make the ammonium 3. It also applies to the hydroxide, makes it 3. 1, 3, 3, 3, 1, 3, 3, 3, 1, 3, 1, 3. That is the balanced formula equation. Next one here, we have antimony and oxygen. Okay, and let's see, we have 1 antimony, we have 2 oxygens. On this side, we have 4 antimony, and we have 6 oxygens. I'd leave the antimony alone at first because it's all by its lonesome. I can put any number in front of it and make them balanced. Oxygen, I have 2 and I have 6. Well, 6 is the common factor. If I put a 3 here, that turns this guy into 6, which means all I have to do is put a 4 in front of the antimony and you're good. 4, 3, and 1 are the coefficients. For this next one, this is the reaction. This is propane and oxygen turning into carbon dioxide and water. Okay, well, it looks like we've got 3 carbons over here, total of 8 hydrogen, and 2 oxygen. On this side, we have 1 carbon, 2 hydrogen, and oxygen. We have 2 and 1, so it's a total of 3. Carbon, I have 3 and 1. If I flop a 3 here, this turns into a 3. And oxygen, 3 times 2, that gives us 6 over here. Okay, not a big deal. Hydrogen, I have 8 and I have 2. If I put a 4 here, that's going to turn this guy into 8. Now the oxygen, I have 4 here and I have 6 here. Well, 6 plus those 4 gives me a total of 10. All you have to do to balance that is put a 5 there. 5 times 2 is 10. 3, 8, 10, 3, 8, 10. 1, 5, 3, and 4 are the coefficients. Okay, let's take a look here. This one. Looks like I have a total of 2 nitrogen. Oxygen, I have 5 plus 1. That's a total of 6. And then 2 hydrogen. On this side, nitrogen, it looks like 1. Oxygen looks like 3. Hydrogen, it looks like 1. All you have to do is flop a 2 here. That's going to make your hydrogen 2, your nitrogen 2, your oxygen 6. Lo and behold, we're balanced. 1, 1, 2 are the coefficients. Okay, this next one we have aluminum, and it looks like 1 of them on this side. 1 hydrogen, and then 1 chlorine. On the product side, aluminums, there's still 1. Hydrogen, we have 2. Chlorine, we have 3. Okay, in looking at this, you may start out and do something like this where okay, the aluminum split hydrogen, I have 2 and 1. Maybe you start by putting a 2 here. That's going to make your hydrogen 2 and your chlorine 2, and that's fine. But then you notice 2 and 3, you're like, 2 and 3, common factor must be 6. All right. And so how do I get 6 chlorines over here? I flop a 2 in front of here, making this aluminum 2. This chlorine becomes 6. And you're like, how do I get 6 over here? Well, sometimes you have to change these. So instead of a 2, we're going to make that thing a 6, which is going to make both of these 6s. All right. If I want to change the aluminum to be 2, I'm going to flop a 2 there. To get 6 hydrogens, put a 3 here. 266, 266, 2623 are the coefficients. Next one, let's see. 1 magnesium, 2 nitrogens. On this side, 3 magnesium, 2 nitrogens. Nitrogen's already good, 3 and 1. All you have to do is flop a 3 here, and we're good. 3, 1, 1 are the coefficients. All right, next one. Looks like 1 iron. We have 2 hydrogen and 1 oxygen over here. We've got 2 iron. We've got hydrogen is 2. Oxygen is 3. I'd leave the iron alone for now, just because we've got it all by its lonesome, easy to fix. 1 and 3, let's flop a 3 here. That's going to make my oxygen 3. That turns my hydrogen into 6. Put a 3 here. That makes this guy 6. Then all you have to do is put a 2 there, and I guess it wouldn't have affected it, but at least we now know 2, 3, 1, 3 are the coefficients. All right, let's take a look here. So this one, we have 1 sodium, 1. Notice we don't have hydroxide over here, so let's leave that as separate elements, all right? So there's a case where there is a polyatomic, but it doesn't exist on this side, so we have to say 1 oxygen and 1 hydrogen, and then there are 2 chlorines. Product side, sodium, there's 1 here and there's 1 here, so that gives us a total of 2. Oxygen, we have 1 here and 1 here, so that's 2. Hydrogen, there's 2. And then chlorines, we've got 1 here and 1 here, which is 2. Okay, well, let's take a look here. If we take this, and we've got 2 sodium and 1, if I flop a 2 here, sodium becomes 2, oxygen becomes 2, hydrogen becomes 2. Hey, that balanced the whole thing. 2, 1, 1, 1, 1. Okay. Next, we've got 2 lithiums here. Oxygen there and oxygen there, so a total of 2. 2 hydrogens over here. 1 lithium, 1 oxygen, 1 hydrogen. All you need is a 2 in front. These all become 2. 1, 1, 2 are the coefficients. I believe we're on the last one. Okay, same deal. There is no ammonium nor nitrate on the product side, so we have to separate these as separate elements. Total of 2 nitrogens, 1 here and 1 here. 4 hydrogens, 3 oxygens. Other side, nitrogen, we have 2. Hydrogens, we have 2. Oxygens, we have 2. Nitrogen looks good, 2 and 4. If I put a 2 here, 2 times 2 will give me 4 hydrogens. Oxygen, I have 2 plus this one is a total of 3. Hey, that fixed everything. 1, 1, 2. And that's it.